Assalamualaikum and hi everyone. Today we're going to discuss on resistive transducer. Now let's discuss on the fundamental concept of resistive transducer. In resistive transducer, the resistance of a transducer varies as the physical quantity varies. The physical quantity can be temperature or displacement. Then, as the values of resistance varies, the value of voltage and also current will also varies. There are two basic devices that use resistive concept for measurement of temperature, which are RTD and thermistor. Potentiometer is another transducer that use a resistive transducer concept to measure displacement. So let's discuss on thermistor and RTD. Thermistor is known as a semiconductor device. This is because the material used is a semiconductor material. Semiconductor material is used in thermistor due to the material properties of the semiconductor. When the temperature varies, the resistance value in the semiconductor material will also varies. In thermistor, it is found that when the temperature increases, the resistance in the thermistor is decreased. Therefore, we can say that the thermistor exhibits a nonlinear relationship between temperature and resistance. The relation between the temperature and the resistance can be explained using this mathematical equation. So here we have RT, which is the resistance value at the temperature that we measured, equal to RT1. RT1 is the reference temperature. So RT1 is the resistance value at temperature reference, exponential, multiply with beta. Beta is the coefficient of the thermistor, and it will depend on the type of material. Next, we have 1 minus 1 over T minus 1 over T1. T is the temperature in Kelvin. T1 is the reference temperature, and common reference temperature is 25 degrees Celsius. This graph shows the behavior of the resistance versus temperature in thermistor. From this graph, we can see that when the temperature increases, the resistance value is decreasing exponentially. And this graph is also having negative gradient slope. Next, let's discuss on thermistor characteristic. The first one is the sensitivity of the thermistor. In thermistor, we can see that the change of resistance is quite big, which is in terms of kilo ohm. For example, if we choose a nominal resistance at 10 kilo ohm, if the sensitivity is around 10% per degree Celsius, then it means that if the temperature increase by 1 degree Celsius, the resistance value will drop by 1 kilo ohm. Second one is in terms of construction. We can find thermistor in various form, which is like these beads and rods. Next is the temperature range for the thermistor. The temperature range for thermistor is considered low temperature because it only able to measure around negative 20 degrees Celsius to 100 degrees Celsius only. So it is quite low. If you need to measure temperature higher than 100 degrees C, then you cannot use thermistor. fourth characteristic is in terms of response time. So for thermistor, we consider the response time to be fast, but it's also depend on the quality of material. Last one is in terms of signal conditioning. So for thermistor, the output from thermistor is in terms of change of resistance. In order to convert resistance value to voltage, we will use bridge circuit. Okay, so this is the construction and symbol for thermistor. So we can see there is a rod type thermistor, a bead type, and it can come in form of surface mount thermistor, leaded thermistor, or probe thermistor. So from the characteristic, we can summarize the advantages of thermistor is that it is low cost and small size. Then due to the high sensitivity, the voltage output of the thermistor is also high. And then the thermistor also provide fast response. As for disadvantages, we know that thermistor is highly nonlinear. The relationship between temperature and resistance is nonlinear. Then the temperature range is restricted to low temperature.